live webinar will be live streamed across multiple platforms that our marketing team is present on. So just hang on, and thanks everyone for joining. And we'll also wait for a couple of more folks to join in. So this webinar is called Developing a GenAI Application with SingleStore Helios on AWS and Anthropic 3. Thanks everyone for joining, taking our time from your day, and thanks to your speakers, Justin. And Justin is from SingleStore and he's a solutions engineer. And we have Saurabh from Amazon, who is it Amazon or is AWS, Saurabh?
It's
Please correct me if I'm
AWS,
wrong.
yes, yeah.
Awesome. Okay. So he's from AWS and he's the solutions architect and amazing experts. And if you have any questions, we have a Q&A button, which is present at the bottom of your console. So you can use it for addressing anything that you might have a doubt regarding. And a Q&A, we will also have a dedicated Q&A session by the end of the demo or like towards the end of the meeting. So if you have anything, just feel free to put it in the chat and we might have a real-time discussion using that. So just an FYI that you are also in a listen-only mode, and anything that is going to be communicated will just be through the Q&A button. So just an FYI, and we don't really answer any anonymous questions. So please include your name or email address using Zoom. So would you like to share your screen now, like either Justin or sort of any one of you?
So I can go over around the core topic of Amazon Bedrock. I know that a lot of SingleStore is doing really great work when it comes to bringing technology where the data can be integrated with generative AI models to create value out of it. And on the AWS side, we truly believe that the whole differentiating factor when it comes to creating value from generative AI is using your own data, right? Like you have your proprietary data, which is like of course private to your organization, and you want to create value out of it for various different generative AI applications. And that's why we wanted to mainly focus around how SingleStore is doing that with Amazon Bedrock, and why as AWS we designed this service so that users to democratize generative AI applications for a wider scale of corporations, right? If I go over on today's agenda, I will be focusing mainly around what's the need for generative AI and give you a little bit of service overview and the key features, right? So from AWS perspective, we know that the generative AI is still a very evolving space. So the core value which we see is for a lot of customers is they are not entirely sure of which large language model to use. There are various array of large language models, and they differ in the capabilities as well, right? At times you don't always need to use a very specific kind of, you want to focus on latencies and other aspects for some use cases, while you want to focus on core capabilities around complex algorithms for in few cases. So depending on your use case, you want to select that large language model. For organizations, they want to move quickly. This is a very evolving space, so I understand that they have to move quickly, and Bedrock was also designed towards that. And we also understand that data is very secure. It's private to your organization, and you would want to keep it secure and not go over public internet in an unencrypted way. So we focus on those aspects too. So going over to kind of know more over Amazon Bedrock, it gives you the capability to have a choice, right? Have a choice of different foundational models from various partners from our side, like AI21 Labs, Anthropic, Cohere, Meta, Stability AI, and even our homegrown Titan models, all under a single API. So you don't have to move over your API to a different model if you want to think about using different language models from different providers. Apart from this, we understand that there might be a need to customize the model. The base models are, of course, very powerful, but they don't probably talk in the language or requirements from your vertical. So you might need to customize them. We give the capability to customize these base models to know more
Pankaj,
about your corporate
actually,
data.
sorry to interject. Like we have some comments from the audience that they say that the screen is not visible, but it
No?
actually is visible for me. So, uh, I don't exactly understand what might be going on. Like if anyone else is facing this issue, please put it in the chat and we can. Yeah, a lot of people can see it also. So I have a
Okay.
comment from they say that they can see it. Okay, maybe like if you can. All right. Can
I
we
can try
just
to share it
try to
again.
share
Let
it
me try
again
that.
because a lot of
Sure.
people can see it. Yeah, just do that.
Sure. Yeah, I will
Thanks,
just.
James, for letting us know, and thanks, Anuj. Seems like they are able to see it now. So
Okay, let me try this. Hopefully, this will work better. If
I think it's fine. Should be all right.
Yeah, so the core value which I wanted to bring out is, which we are also for to here to know is around the RAG use case, right? So retrieval augmented generation, where you get value by sending the large language model the relevant data from your business so that it can extract that context and give you back contextual answers. And that's where SingleStore comes in. You can take advantage of SingleStore and tie it together with Bedrock. Other aspects are towards agents where you can actually do actions, not only just get response output in normal English language, but take an action, probably call an API and automate things on your sides. I know businesses are very much interested into doing more with agents, and that's where we see a lot of uses evolving from our customers as well. And apart from that, Bedrock provides you a secure private with a privacy focused and safe mechanism to build your generative AI applications. So the core thing which I want you to take away from the core, like if you don't get anything out of my talk, but the core thing which I wanted to give from Amazon Bedrock side, it simplifies your choice, helps you with customization, and integrates with different databases, and gives you a very good security and governance model. So these are the key things I would say. There are four things which I would want you to take away from this. Uh, I know that we provide a lot of different, choice of models ranging from various partners. I want to focus on some of the Anthropic models. Anthropic recently came, like this week itself, came with a 3.5 Sonnet updated model, which much higher capabilities. And I do want to focus again on the key aspect here that uh, there are different capabilities when it comes to different models, right? So if you see here the most intelligent model, 3.5 Sonnet right now has is of course the most complex. So any complex workloads which you have, right? We would want you to use the that model specifically. But at the same time, uh, we also have Claude 3 Haiku, right? So this is the fastest performing model at the low cost. So let's say there are use cases where you want to create a chatbot there where you first want to identify, okay, which specific department is more relevant to this chat question. Those kind of classification or small decisions can be probably taken by a faster model, and more complex decisions can be taken by uh, as probably Claude 3.5 Sonnet. So based on your requirements, use the different models and take advantage of the you know pricing advantages there as well, apart from latency, right? Uh, so again, we want to focus on the Amazon side. We also have a whole family here of Amazon Titan models. These can be used towards generating embeddings as well. So let's say for in the RAG use case where you have all your data and you want to vectorize your data, you can take advantage of Amazon Titan embedding model to vectorize that data and then use a large language model like Anthropic to to kind of get the only the relevant documents and then probably get that contextual answer, right? So I will also focus on key aspects around model evaluation. So I understand that customers want to try out different models, and then the need arises of how do you evaluate that. There are benchmarks available for a lot of the models, but at the same time those benchmarks are on a data set which is public and a very specific data set. For your corporate data set, things might differ. So you might have to, of course, you do evaluation for models even for your data set, because that's different from what these models were trained on and benchmarked on. So when you do these evaluations, you can take advantage of Amazon Bedrock capabilities as well, where it can evaluate models automatically or even with a human evaluation. And you can use curated data sets from AWS side, or you can bring your own data set. So if you have a corporate data set which you actually want to see how things will happen in the real world with your own data, I would definitely say bring your own data set and actually see how these models perform with a real data set. Going into how the customization approach works for foundational model, if you are on the journey to leverage large language models and even look into RAG, I would say the first focus would be on prompt engineering. You would want to leverage prompt engineering and see different ways in which you based on your prompt, the LLM is performing. Probably also keep a record of all your and version all your prompts there. The next thing would be around retrieval augmented generation. What we see that the most value out of any large language model you can get is when you give it your own context, right? Your own data set, so it can get that relevant data out. It doesn't mean you can immediately start using it. You have to get ready to, you know, the first part will be you have to vectorize all your data set. So then the large language model can actually start looking into it and getting the right context from your data. Right? Another thing would be on the fine tuning. So I understand that RAG is very efficient when it comes to getting the right context, but remember this, uh, as you have to give more and more context for the model to understand and give the output as you desire, that might not fit into a right approach. So you have to use various different mechanisms to limit the amount of documents which you send in the RAG. And that's where fine tuning comes in. If you want to train your model to give output in a certain way, you want to uh, train your model based on your vertical business and the language you speak, fine tuning might be needed there. And the last one is continued pre-training, where you're actually creating your own model, right? And as you see here, the complexity and the cost will increase as you move across from prompt engineering to continued training. Uh, but I would definitely say like prompt engineering and retrieval augmented generation is the cornerstone that any generative AI application should be using to get most value out of generative AI. On the Bedrock side, as I said, like the prompt part, we are actually building a prompt builder. We have a prompt builder as well, so you can actually build your prompts and also create a prompt library to manage the iterative process, because you would want to check how you find the right prompt and then reuse that, or even test, do various different tests for your workflows, right? So Bedrock provides you a mechanism to do it. We have also Bedrock prompt flows where you are able to kind of keep versions of your prompts and even test specific deployments where uh, you have a chain of specific test cases which can go through, and you can reach out to language models multiple times, right? So that's another thing I want to focus on. So we are being on the knowledge base side, we are adding multiple data sets as sources. So you can actually bring data from different sources onto Bedrock and then actually use them to embed the data, right? So that's another very useful use case where you want to build that your corporate data and bring that onto your database, so you can take various specific advantage of it, right? Yeah. Let's go into certain key aspects around how different is fine tuning than continued training, right? So fine tuning is going to be required for your side for knowing very specific tasks, right? So if you are looking and working in a specific vertical and you already have data defined that, okay, this is what if I'm working in medical vertical and I know that I want the data output in a specific format, this is the specific context and this is my output. If you already have that labeled data, you can use that to fine tune your model to improve your accuracy, right? With continued pre-training, you need a lot of it's almost like training your own large language model, which might be relevant only for specific data set. But again, you can work with a labeled data set, but at the same time, it might need a whole team and experts to do this. So what we are helping customers is how can you easily do the fine tuning part, which is not a very heavy lift, right? How can you do that? So we are actually one of the providers, which for Anthropic, the most powerful models from them, the Claude 3 models, you can actually bring them and fine tune those models on AWS. At the same time, remember this, the data which you bring to train this can be encrypted with your own customer key. You can even have the data sent through private link. So all that data is not going to go through any public internet. And remember this, that the data is not shared with the model provider. So any model you are fine tuning on AWS side, that data is not going to be shared. So that's another key advantage which we have on this. So at the same time, fine tuning is the next step, right? Like the first step was the RAG. And that's why I would like, Justin to come in here and share how you can take the core advantage of, Amazon Bedrock and first bringing in that RAG feature, because like you can do prompt training and prompt engineering, but the main focus is how to get to the next step, RAG, before you fine tune. Fine tune is also another step, but yeah. So Justin, if you can show how what great, amazing work your SingleStore is doing to bring that retrieval augmented generation with Bedrock. Yeah.
Sure. So first and foremost, Saurabh, thank you very much for that great explanation. What I'm going to do now is exactly as Saurabh said. I'm going to walk you through a couple major pieces. The first one is let's talk about SingleStore. I saw a couple questions in the chat and I was trying to respond to them little by little, but here's the big thing at the end of the day. SingleStore is a hybrid transactional analytical database platform, which, by the way, absolute mouthful to say, but let's simplify that a little bit more. When we think about the landscape of database services, you have databases that are great at ingesting data, the transaction side. You have other databases that are great at analyzing data at scale. This would be your big cloud warehouses. The other piece are standalone vector databases. Now, at the end of the day, SingleStore actually combines all of these and more together in one unified hybrid architecture. What I'm going to do now is I'm going to share my screen. And throughout this process, we'll talk about SingleStore from a general perspective, from the hybrid side. We'll talk about the vector capabilities. And of course, we're going to end on a real life demo where I've actually gone out and integrated Amazon Bedrock with Claude 3, brought it through into SingleStore, actually generated the embeddings in SingleStore, and then gone and actually analyzed the data. Now, throughout this process, if you have any questions, please put them into the chat. I really encourage you for that. Okay. With that being said, I just want to make sure if people can see my screen. So Yukti, Saurabh, if you could just let me know if you can see this.
I can see it fine. Actually, the issue sometimes might be with the browser version of Zoom. So I just have a
I
request
see.
from the audience. If there's an issue, please try to rejoin using your Zoom app. I mean, it's
Yep.
working fine for everyone there. So yeah, thanks, Kristen.
Yeah, no problem. And so when we're going out and doing this, this is actually a presentation that myself, Saurabh, and a wonderful person named Ali Hukro did. She's actually from Anthropic a little while ago in person. So we wanted to make sure that we're bringing this out to everyone here and really open this up to a much larger audience. So with that, let's actually begin. SingleStore has actually been around for quite a long time and very much in the stage of a late stage startup. The idea here is we've been around since 2011. And the big pieces on here, and there are really two or three that I want to start with. Now, SingleStore started as an in-memory database, right? Way, way, way back at the beginning. When we looked at 2014, that changed with what we call our three-tiered architecture, which we're going to get to in the next slide. The big thing here is we went from pure in-memory to row store, right? Your in-memory, and column store, meaning that we can actually analyze data just as efficiently as we can actually ingest data. The other big piece is in 2017, well before we think of a lot of the spate of other databases and big LLM companies coming out now, whether that's OpenAI, LangChain, or the like, we've had vector support since then. And so the big idea is we developed vector support for two major customers. One was an incredibly large bank, and the second was a company called Thorn, which helps fight human trafficking throughout the world. And so with that, that speed, that simplicity, and more importantly, that vector support allowed them to really not just continue, but more importantly, push into hyperdrive their search to really end human trafficking. And the last piece is really this, okay? Since that time, and you see this right here, SingleStore has actually grown quite a lot, right? And so most of our customers are actually large Fortune 500 companies. And you see that right here, 400 plus customers, right? 100 million 5 ARR. Now, here's the big thing. And if you take nothing else from my presentation, this is it. SingleStore is a platform to transact, analyze, and most importantly, contextualize, not in days and hours or even minutes, but in seconds and milliseconds. Now, what does that really mean for us here? And so I want to break this down. Let's first start about transactions. Basically, how do we ingest data? The way that we would recommend is something that we call pipelines, which is this massively parallelized ingest process. It can take data from blob storage, whether that's AWS S3, Azure Blob, GCS, Hadoop, Kafka, and ingest that in seconds. And let me give you a great example. I was working with a customer recently. They had 7 million data points that they wanted to ingest it, and their goal was in under a minute, right? Not only did we meet that, right? So 7 million data points ingested, not just at a minute, but well under a minute. So a lot of data can be brought in incredibly efficiently. And these pipelines are incredibly simple, 5, 10, maybe even 15 lines of SQL code at the end of the day. And that brings me to my next point. SingleStore at the end of the day is a hybrid platform based on SQL. So if you, wherever at Oracle DBA or work with MySQL or just generally ANSI SQL, then you're going to be right at home in the SingleStore platform. And it's compliant across the board, which is really fantastic. And the other piece here is because we're talking about our cloud deployment, SingleStore is horizontally scalable. When we think about vertical scalability, of course, we can add better hardware, better CPU, better RAM, better even GPUs now when we start thinking about LLMs. But what SingleStore can also do is, in a matter of, and I mean this seriously, 5 button clicks, you can scale your database incredibly efficiently and incredibly easily, meaning that you can add additional resources and storage into the cluster seamlessly. 5 button clicks. Now, the next piece is on analysis. The idea here is we want you to take your data in, but how fast can you run it? How fast can you analyze that data? With SingleStore, any bit of data that's written in is analyzed at the millisecond, right? It's been committed. SingleStore is a 100% ACID compliant database as well, meaning that any bit of data that's written in is fully committed down via 2-phase commit. You can analyze it on the millisecond that it's written into the database, and you can analyze every layer and level of the data that exists within that database. With that being said, what data can SingleStore support? If you think about a standard relational database, everything from a Snowflake, for instance, BigQuery, or Amazon RDS, right? When we start thinking about a lot of these cloud databases, the idea is, of course, SingleStore can handle relational data, text, bar chart, int, big and small and all the like. But what SingleStore does incredibly well is also handling JSON and vectors, which we treat as first-class citizens, meaning we don't just store them in blob, we actually store them as their own specialty data types. And this allows us to be incredibly efficient, not just ingesting, but more importantly, analyzing, searching, and working with these data types as a whole. Now, the big piece here is really on contextualization. Okay? It's great that we have all this data, and so many companies do, sometimes hundreds, if not thousands of terabytes or even tens of petabytes of data. But how can we actually get information out of it? And that really comes down to context. The reason we're talking today about SingleStore is really that not only can we take in data and we can store it in a database, but in one single table. That's right, one single table, I can have my data, my metadata. I can even have my vectors and my text all in one single table right next to each other. Now, this gives us a lot of benefit, which I'll talk a little bit about later, but the high level perspective is simplicity is key here. I have all my data sitting right there, meaning I'm reducing latency, centralizing, right, my data, making it incredibly easy to pull from one source, reducing cost, and more importantly, the data can actually be versioned incredibly easily. And the big piece here as well is that SingleStore can be run almost anywhere, whether we're thinking bare metal or virtual machines sitting in AWS like an EC2 or Kubernetes cluster, or even in our own managed service. Now, with that being said, let's talk a little bit about how it works going through the architectural side. We've talked about pipelines, but let me state something really quickly. Super easy to set up. And I'll give you a great example. I have data sitting in an S3 bucket. Okay, so I've loaded all that data in. I need to get that data from the S3 bucket all the way into SingleStore. We have a pipeline now called an infer pipeline, which is another type of pipeline that reads against the bucket, reads against the file, and actually the output is the DDL, meaning the actual table create statement and the pipeline create statement. What this means for me is that I can go from an idea, data sitting in an S3 bucket, all the way to data sitting in SingleStore in 2 to 3 minutes. Blazing fast. And this can be not just a couple hundred megs, this can be tens of gigabytes really easily. Now, it's great that we can take in this data, but what happens with it? Ultimately, when data comes into SingleStore, it's written first into our in-memory row store. This means millisecond level reads and writes. Your data can be written in and committed down incredibly efficiently. But not every bit of data is stored in RAM. And so the idea here is each table, and when we're talking about a persistent cache, we're actually just talking about storage. SingleStore doesn't cache results of any variety. And so when we tell you that our response times are incredibly strong, this is why, at least part of it. The idea here is data that's not written into memory goes directly into the table. And that data, of course, it can be analyzed at scale, but it's also compressed down. Depending on the cardinality of the data or the variability associated with it, that data can be compressed anywhere from 70 to 80%. Now, we're here talking about vectors. And so the idea here is vectors are probably compressed anywhere from 20 to 30%, again, depending on the cardinality associated with it. What this means in the end for you is you're saving money. You're not just storing data in an uncompressed format just because. The idea is no matter the data or data type, it can still be compressed down, saving you a little bit extra. And the biggest piece here is that as data ages, we want to store it in the most efficient place possible. Enter the Cloud Object Store. So if we were to lens this in an AWS perspective, up here, this memory and persistent cache, when we start to think about the entire cluster, it's generally on a Kubernetes cluster or an EC2. This right here, the cache, is fundamentally an EBS. It's actually an SSD sitting as GP3s. And our Cloud Object Store is an S3 bucket. Now, as I mentioned before, as data ages and you continue to push more data into the system, we want to store it in the most effective way possible. And so if we think of this as hot, warm, and cool, the data will be pushed down and stored on ice in a custom compression method, again, saving you money. When you need that data again, simply run a SQL query. That's it. You can either warm it yourself or any query that you run that hits that table, the data will be warmed. And we're continuing to push on advances to make that even faster. In our most recent update, we actually put out an option that allows users to speed up the return of that data 5-fold. So blazing fast. Now, if we were to abstract this, let's talk a little bit about the user side. A user interacts with an application layer. We're here today, and so let's call it an AI ML application or a chatbot. A user wants to interact with an LLM, and so they make a request. That user interacts with that LLM, and if SingleStore is being used, that request, for the data actually gets sent to our aggregator nodes. The aggregator nodes know where the data is stored in our distributed SQL database. And so they send the request down into what we call our data nodes or our leaf nodes. A leaf node is our storage and our compute harmonized. But the cool thing is you can actually scale these up independently or together in a matter of minutes with only a few clicks. So that request from that user hits our application layer, it hits our aggregator node, and is pushed down where it grabs the data from these two leaf nodes, pushes it back up, and right back out to the user. Now, this is a slide that I'm just going to leave up and I'm going to talk about only a bit. Everything that I've told you so far really lends itself to this, right? Query response times are blazing fast. And I've seen this not just on a couple of gigabytes of data, but on petabytes of scale. And we actually see this up here. This is one of our largest customers. They have 50 petabytes of data stored on SingleStore. So quite a lot of data. But the big thing here is, even though you have a lot of that data, the average read response time is 1 to 15 milliseconds. So let's put that in some context. The blink of an eye is 10 milliseconds. And so here, when you select, this information from this table, your response back is blazing fast. The other piece is SingleStore works incredibly well in high concurrent environments, meaning that high concurrent, low latency environments are where SingleStore thrives, whether that is updating dashboards, analytics and reporting, transaction ingestion, and some additional unpacking. SingleStore can really sit as the nexus of a lot of this. And so this really brings me into the heart of why we're here today, and that's on the generative AI side. Okay? I've talked a lot about how SingleStore can actually take a lot of this data in, how we can analyze that data. But let's put this in the lens of AI and vectors. What we see up here is quite impressive, but let me actually contextualize this a little bit more for you. Take the bottom one, 17 million characters per second. Sounds like a big number, right? But what does that ultimately translate to? So if you or your children ever read the Harry Potter series, Harry Potter has 7 books in it. And if you translate 17 million characters, that's like reading the entire Harry Potter series, all 7 books, 3 times over. That's not in minutes, that's per second. As you can get the idea, SingleStore can ingest quite a lot of data very efficiently, whether we take it from blob storage, Hadoop, Kafka, or a variety of other mechanisms, whether it's Python libraries, Spark connectors, or even new CDC pipelines. The idea is SingleStore can take a lot of the data in and analyze that data at scale. Now, Saurabh did a really amazing job talking about this earlier. Okay? There are so many ways that we can think about how data, especially the LLM space, is ultimately moved in and how the LLM is trained. When we already have an LLM, when we start to think about the value, right? So basically the cost to the experience, right? One of the most expensive is ultimately going to be retraining the model. Some of these models, these large LLMs, could be 100, 200, even a couple $100 million just to train and build. And so retraining can be incredibly expensive. When we think about fine tuning, less money, but not always necessarily with a scalpel, right? It can leave a lot of issues or a lot of problems sitting within the LLM that ultimately will yield poor responses back to the user. And the final piece is RAG, or retrieval augmented generation. Bite-sized, ready to go, easy to be updated. And so if I were to put this into a little bit more context, right? When we think about a typical enterprise, it starts very easy, right? You have a product, you have some customers, and the idea is you want to sell that to them. And so when we start to build out that chain, we have an application, for our end users, of course, we have a transactional system to take data in from that application. That data has to be translated over just to get it into an analytical platform. And on top of it, of course, then we run analytics. And we have everything around us that could help support our sprints, our issues, whether that's Jira or certain boards, right? And while this starts simple, let's just say our application is growing. We now have a lot of additional pieces to speed up that application, to understand how users are fundamentally interacting with it. And so we put on caching. We want to stream data in. We can also implement search like Elastic or Solar or even SingleStore. The point here is that complexity doesn't really scale well. And in the age of vectors, it only gets more complex. The most important thing about a vector database, and this is so true here and in the subsequent slides, is that you're only as fast as your slowest component. And because of that, SingleStore is really here to simplify this. If we lens mostly on the vector database side, let's kind of peel this back a little bit further. If we look at RAG, what we ultimately have is a really simple pattern, right? A user comes in and they interact with a GenAI app. Ultimately, the user gets back that response. But what's under the hood has a huge impact on user experience, not just the quality of the databases, but potentially even the quantity too. And so in a traditional system, when a user interacts with a GenAI app, they will go and when they hit that, it stitches the data back together. Round trips from the transactional system, round trips from the analytical system, and then eventually the vector database. And before you can even give a response back, it has to go all the way back up, right? We stitch the response and then we pass it through as context back to the LLM. This adds a lot of latency. It adds a lot of cost through egress, and it adds potential problems with any of the translation, any of the connections between the databases. If we were to simplify this a little bit further, this is really where SingleStore comes in. As I said at the top of this presentation, SingleStore is a hybrid database platform, meaning it takes transactions, analytics, vectors, and even search, and stitches it into one unified platform that reduces cost, reduces time, reduces latency, and reduces complexity. What is this? But ultimately, what does this really mean for you and for the end users? It means less cost, faster, and better responses. And when we start to build in with Bedrock as well, we see that it only becomes more powerful. We have additional guardrails, quite literally called guardrails, right, in Bedrock. We can choose models with really strong surety that they're safe, they're secure, and then we can easily and effectively implement them in SingleStore in minutes. And so if we start to abstract away a little bit more, what are 3 key developer needs that are solved by SingleStore? The first one is going to be on text-based search, right? Lexical search. Direct lexical search, whether we're thinking Elastic or Solar or even SingleStore, all actually utilize the same engine. We're just as fast and just as powerful. But the benefit is with SingleStore, you actually get the full analytics, transactions, search, and vectors in one spot, not search, vectors, transactions, and analytics in completely different areas that have to be brought together. The next one is on vector search, right? I don't have to go too far into that. That's why we're here. But I'll say this, and this is really the biggest piece. Vectors are one of the most important things that we're going to see continue to push in the next 10 years, right? We've already seen a huge shift in the way that businesses actually do business and engage with their customers, chatbots, RAG, and really the sky's the limit at the moment. And so that ultimately brings me into the last piece, which is on hybrid search. Now, if we were in an audience, right? If we were in person, I would ask you just by show of hands, how many of you have heard of hybrid search? But clearly not possible here, so I'll explain it a little bit further. When we think about hybrid search, we have to break it down a little bit. On one side, we have what's called lexical search, right? On the other, semantic search. Lexical search is pure keyword search, and semantic search is just that, semantic, right? It adds meaning to our words. But what if we brought the two of them together? The idea here is when we do a lexical search, we are looking for specific keywords in a data set. And if we actually push that in on the semantic side, so we take that lexical search, we search for specific keywords, we can push that into the lexical search as context. Every LLM has a context window associated with it. Some are bigger, some are smaller. And it's the same reason that when you ask an LLM a question, you don't simply just hit enter, right? It has no idea what you're asking about. You have to actually type something in. In this case, I could type something like, you are a solutions engineer, and you're giving a presentation with Bedrock, Anthropic, and SingleStore. What's the best way to integrate these three together? That's direct context into the LLM that it can then use to actually give you a proper response. By combining the two of them together to create what's called hybrid search, you actually pass through a lot of additional context into that window and narrow down the scope of what you're looking for in the semantic search, thus giving you better responses that you can actually now weight. Now, all this is great, but we're getting a little bit up there in time. And so I'm gonna, basically bring us to the end now before I go into the demo. Here's the big piece around this. When we start to build generative AI apps, you have to ask yourself, well, what's the best platform? It may be great to get a single node database right now, a PG vector, a Milvus, for instance, and yeah, you could scale them, sure, but it's not easy. It's not truly scalable. And the big reason for that is ultimately down to their architecture. SingleStore is actually meant to be scaled up and scaled down as your applications grow, as your user base grows. And so when we think about this further, SingleStore can handle structured and unstructured analytics, right? JSON, vectors, and on the pure relational side, the structured piece. Vector and keyword search, as well as even live vectorization, where we can actually generate the embeddings in SingleStore or generate them outside of SingleStore incredibly easily. And of course, imagine instead of having that additional latency, that trip back and forth to your analytical platform or your transactional platform, you can do it all in one in simple SQL. At the end of the day, the idea here is simplicity, it's scale. Okay. With that being said, I'm going to stop sharing right now, and I'm actually going to go bring up the demo, and we're going to go through this. Now, I brought this, and I'm hoping it's going to still work because of the way that our keys work. But let's actually go into a really, really quick architecture, because I realized I probably should share this. I think that's probably going to be very, very important. Give me 1 second. Let me just make sure this is resharing. Cool. Okay. And so if we think about this really simplistic architecture, here it is, right? Let's focus on SingleStore and go from the left, and then we'll go to the right. So in this scenario for this demo, SingleStore is sitting as really the nexus between our LLM, our transaction analytical and vector capabilities. So data has been written in from an S3 bucket. We took this data from the Amazon store. Now the idea is we wanted to take data that's more relevant, that has reviews. And so we went to the Amazon store, found it around Amazon Prime purchases. So these are reviews that people left for purchases that they made for different media content, shows like Breaking Bad or Mr. Church. That data was brought in a pipeline that took us literally under a minute, the data blazing fast written into the database. On the right side, then we start to think about how a user actually interacts with that data. A user asks a question, the same way we're going to do today. It hits the LM, right? So actually goes to Bedrock, where we've actually enabled Claude 3, right, for Sonnet. And then that hits SingleStore to run the SQL, pushes the query results back, and ultimately gives us a response back as natural language. Okay. With that being said, let's actually go into the demo, right? I'm going to bring this over here, and I do apologize. It is in dark mode. That's just how I prefer it, and it's just a little bit easier. Okay. So let's start talking about how we did this, right? Cool. Cool. And so what I've done is I've skipped over a couple of the major pieces here, mostly just around my credentials and anything else, but here's how we did this. I brought in 4 libraries. That's it. JSON, SingleStore DB, which is how we're connecting to SingleStore. I brought in the Bodo 3, right, to be able to connect to Bedrock. So right there. And then I brought in the vector embedding, which is actually coming from Voyage AI. And this is because Anthropic actually doesn't have its own embedding model associated with its LLM. And so they recommended another one. So this is what I used. And really, actually, let me rephrase that, what we used. So this was built by myself and another really phenomenal solutions engineer named Rohit Bamidapati. So I just want to make sure I give him a ton of credit as well. And so the first thing we're going to do is we're actually going to connect to SingleStore. And it really is this easy. You simply pass through these environmental variables that you can get from the SingleStore portal, right? When you sign in, you get all this and simply we auth, right? So the connection is good, which is great. The next thing we also do is we have our vector embedding function. Now, what we did was we actually embedded this data in a separate function just to make sure that this was really clean and clear. And so what's going to happen is with this embedding function, any request that actually needs it will be called against it, right? So this is a quick reminder. Anytime that you create a vector, right, when you create that vector embedding, if you want to actually search against it and really use it, then more than likely, right, unless you want very strange data, you should probably be using the same model that you use to embed or generate that vector embedding. So just a really important point there. The next piece we did, and I'll kind of linger on this a little bit, is what we call our semantic review finder. This is more of a general search. Now, what this is really doing is, fundamentally, and you can kind of see this. So it will be using a semantic search, right, to find the relevant reviews, generates a vector embedding off of what we're sending back, and then synthesizes the output. Okay, so this is using every aspect of that, from the vector embedding piece on Voyage AI all the way through ultimately the Claude 3 Sonnet model. Okay. And so I actually did this right beforehand. This is just more for time than anything else, but I literally did this right beforehand. And so the idea here is if I did this, what's going to happen is, query text, I input the text. So let's try this. Maybe it can actually work. And there's going to be a pop-up at the very top. So I am a big fan of Pierce Brosnan. Okay. So that's what I'm going to do. And this is going to take a little bit of time. And the reason it took a little bit of time was because I was slow responding, right? Otherwise, this can be as fast as a couple 100 milliseconds, depending on how fast you can type, right? If you're really fast, then this query responds, because we've tested it in SingleStore otherwise, it actually technically responds in about 4 milliseconds, and then it does this round trip to show the UI. So still blazing fast. And if we look at the bottom, this is what the data actually looks like, right? We have our review, our rating rather. Then we have the review associated with this. Right, we have this again. This is just based on the title associated with it. So the way that Amazon inherits, we have some specific ASIN, Amazon Store Identification Numbers, same here as well. And we have some date times associated with this. If I go down further, this is ultimately where we bring in the Claude model, right? And so this is actually pretty cool. The first thing I want to call out before we actually go down is this. We can bring in Bodo 3 via library, right? And we pass through our authentication, our credentials, right? But the big thing here is we still have to call ultimately Bedrock at the end of the day and the model associated with it. And that's really what we're doing here, okay? So if we see this is calling the Bodo 3 library, and this is going to be calling the model, okay? And we see that right here. So we see this for Bedrock right here. And also ultimately, here's the model that we're using, Anthropic Claude 3 Sonnet, and this is just the version release, okay? So at the end of the day, this gets us a little bit of information. This is basically a text search, right? Just to make sure that we're on the right path. And then if we go down further, this will actually take a little bit. So I'm going to hold off on running it. And the reason is because it's round tripping it. The data in SingleStore is very fast, but it still has to round trip, right? And which can add some time. And so the output of this, right? If I typed Pierce Brosnan, okay, in, I had these reviews. And if we look up top, this is what we pass through as context back to the LLM. Your role is to interpret the provided vectorized review data and deliver a comprehensive analysis in one paragraph. Focus on integrating the main points from all the reviews into a simplified, cohesive summary that can be easily understood. And let's go see if it did that. If I go down, and this is just the output of it, based on the vectorized review data, here's a comprehensive analysis. Most of the reviews are highly positive about Pierce Brosnan's performance as James Bond, which, hey, maybe that's a little subjective. I loved Pierce Brosnan, but everyone's a little bit different, okay? And this is really true across the board. So we have a high level piece. We see some dissonance, right? They express some criticism or mixed feelings. And then we have the overall when we start thinking about sentiment analysis. But let's take it another step further. This is another pattern that we wanted to explore as well. Instead of using the vector embedding, right, a pure semantic search, what we're doing is instead doing an actual lexical search, right, to pass context into the LLM that can then take it and synthesize a better result for us. And so it's exactly as it says. We're going to use lexical search to retrieve all the relevant reviews for a given title. pass it as context, and then it's going to synthesize a full review. Now, the difference here is instead of passing through an actor, we're passing through a title. Now, the title that I had passed through before was Breaking Bad, the final season. Okay. Fives, as you can kind of see across the board, right? So really, really fantastic. And of course, we have the reviews right here. Now, what's interesting here is, and you see this up here, right? I selected the title, I selected the rating, I selected the review text, and we see that right here. Okay. If I go further, it's the same exact idea, right? What instead, I'm not really passing it through as the embedding, but the idea is I'm passing this through as context back in down to the model. And so this is actually a slightly different context that we're giving to the model, or slightly different instructions. You're a professional movie review aggregator now. Your job is to take the existing reviews and synthesize a 3-sentence output that summarizes the sentiment. You are not to reproduce the exact reviews, but you can use a subset of language from the reviews in your response. Also, mention the number of reviews that were used to construct the response. Now, let's go see if it actually did that. If that's ultimately really why we're here at the end of the day. And if we scroll down, we'll actually see this. Based on 16 reviews provided, the final season of Breaking Bad was widely acclaimed and loved by viewers. Okay? Many described it as excellent, great, and perfect ending to the critically acclaimed series. While some found the subject matter intense at times, they were captivated by the acting and storytelling until the very end. Overall, the reviews convey an overwhelmingly positive sentiment towards this gripping conclusion to the television's most celebrated dramas. Now, if we look up top, we see the reviews. My husband loves this title, right? This series, and watched it a couple of times. Don't want to put any spoilers in the reviews. I don't want to ruin the final season for someone who hasn't seen it. If you like Breaking Bad, you've seen all the rest of the seasons, right? And so the idea here is what we can do is add tremendous value incredibly simplistically. To give you some idea, this probably took us 2 hours, 3 hours total, and that's just to make sure we were fully testing it. We did a little bit of A/B testing to make sure that everything was proper and correct, and it was counting, right? What we're trying to do is we're trying to avoid hallucinations, and so that's why we actually see a lot of the text being output. We want to make sure it works. Okay. With that being said, this has really been just a bite-sized taste of this. And so what I'm going to do is I'm going to end on one final slide just to really wrap everything up, because I think it'll make a lot of sense this way. When we think about SingleStore, right, this is really it. Okay, this is really it. SingleStore can easily sit at the heart of intelligent applications. Now, this doesn't mean that SingleStore has to be the only database. But the idea here is SingleStore can work as a complement to an existing database platform. Whether we're thinking an analytical platform like a Snowflake or Databricks, or even a Cloudera theoretically, or even a transactional system like a MongoDB, for instance. SingleStore can work incredibly well with and also on its own. And the idea here is we can take data in incredibly efficiently through our pipelines, what we call streams as well, through CDC in and also CDC out, as well as direct ETL. And we believe in this so much that we actually acquired a company that does purely CDC to help our customers. Once in SingleStore, you have the power of transactions, analytics, search, vectors, all in one. One cost, one place, one single store. And when we open this up a little bit more on the LLM side, we also could bring in Bedrock incredibly easily. Photo 3 was called with just a library. That's it. So that was all in Python. What I did was import Photo 3. That's the same when we're taking S3 buckets or wanting to push technically data to an S3 bucket or work with it, as well as Bedrock. And so this is the entire Amazon ecosystem to a large degree. And so at the end of the day, if you take nothing else from this presentation, here it is. SingleStore is a platform meant for high concurrency, low latency, transactions, and analytics. If we had to break that down even further, SingleStore is really fantastic from a use case perspective at operationalizing data at scale, reporting, analytics, data ingestion and unpack, search, and even vectorization of content, right? Whether we're vectorizing in SingleStore or even ingesting vectors and operating as a vector database. At the end of the day, the last thing I'll leave you with is this. when you are going to be choosing a database, don't just choose a database for today. Think about the future, right? Think about where you're going to be in a year, 2 years, 5 years. If your answer now is, well, let's get something open source because it's inexpensive, hey, makes sense. But understand that that decision will hurt you long term, right? Free, especially in the time of open source, it's not free. It's free like a puppy, right? They're cute, they're fantastic right now, but they're going to grow up to be a dog, and you should be ready for that, okay? And SingleStore gives you the opportunity, more importantly, to scale. So it can scale with you as your application grows, as your concurrency and latency needs grow, as your application becomes more robust with more users. With that being said, I've shown a lot and I've talked an absolute ton. What I want to leave you with is thank you. Thank you for taking the time. Thank you for being here. And thank you for listening to us today. Okay, Yukti, I'm going to give it over to you now.
I loved the Breaking Bad reference there. That was really cool. So yeah, so now we are open for questions. We actually just let me know that you're able to see the Q&A like this entire console. You're able to see that, right?
Yeah. Yep, absolutely. So let's
So do you
go
want
through. Yeah, let's go through
okay,
these from top to bottom. I think this is excellent. So
awesome.
here's a
Awesome.
yeah. So Raja Safi, hey, great question. Same with Rupesh Kumar, right? So let's start at the top. What's the difference? What's the different services or quality and other cloud services? Okay, so from a high level perspective, right? What is the difference services or quality from this cloud database? Right. So SingleStore can be deployed on the three major public clouds. It can also be deployed on VMs, right? Your choice of where that's going to be, as well as bare metal, right? Or Kubernetes as well. And so the idea here is with SingleStore, you're getting a platform that has between 3 nines and 4 nines of availability, meaning that it really shouldn't be going down. 4 nines of availability, by the way, is 53 minutes of downtime in a year. So very little. It's already highly available. We have security out the wazoo, encryption at rest and in transit. And the biggest one here, I would actually say the two biggest ones here that really differentiate us from a lot of other database platforms is going to be the people. And it's also going to be the product as a whole, right? So not every database can handle transactions and analytics and do it well, right? Especially in highly concurrent environments. That's the big one. But the other piece is on the people side. When you do a POC with SingleStore, you don't just get someone like myself, you get a whole team around you. And I don't mean that from the, hey, you get one other person, right? We'll bring in engineers to help optimize your queries during the POC. We'll bring in the heads of product or the head of support or whoever you need to feel incredibly comfortable. When we think of it, think about it from that perspective, really that's why you're choosing a database. It's because, yes, the technology is fantastic. And we've proven time and time again, whether that is helping a customer reach 78,000 queries per second on simple queries or 12,000 queries per second on medium to large queries, or even ingesting tens of millions of data points in a minute, right? We absolutely have the capabilities to do that. But the big thing is it's around the people. Okay. I want to go down to Raj's question. What's the difference between other vector databases? There are a couple, right? Standalone vector databases are great for what they do, but they're a vector database alone at the end of the day. And so you actually miss out on a ton of context. If we think about a slide earlier on where I was showing the RAG, right? You have a vector database, and yes, they can ingest incredibly efficiently, some even better than SingleStore, right? But at the end of the day, SingleStore can handle and generally performs incredibly well, especially with pgvector and Milvus, right? We have comparable response times, comparable ingestion rates. And so ultimately, you get same comparability, but you also get analytics and transactions in the same table, meaning that you don't have to have 6 different licenses, 6 different master agreements, 6 different databases and companies you have to work with. You just have one. And here's the other cool thing. SingleStore doesn't operate on a per query cost, right? It's like an EC2. You build up an EC2, you know it's going to be, let's just say $2 an hour. You can throw as much load on that as you want, whether that's vectors, analytics, transactions, it doesn't matter. So you could do quite a lot. But here's the last one that really separates us. Most vector databases do not have role-based access control and row-level access control. And what I mean by that is every vector, every single line in a SingleStore database can actually be tagged with a row-level access, meaning I can tie an exact role, so a user, a group, a role, back down to an individual data point. Meaning in one single table, I can actually have my RAG app just look there. And what's going to happen is we build out these really secure views that whenever a user comes in, they can never SQL inject. They can't change around what group they're in themselves. It has to be done by an admin. And that means that every time they come in, it's just very easy. It's an authentication and authorization check. And then they just get the data that they're allowed to get. So those are some of the biggest ones. Now I want to go down to the next question from Arti Peshkar. We use Databricks for our data cleaning, preparation for model training. Can you compare how it would be beneficial to use SingleStore instead of Databricks? So this is a really great question. And as you saw from that last slide, right, that kind of harmonizes everything together. SingleStore can work incredibly efficiently from an augmentation perspective with Snowflake and Databricks, right, and Cloudera as well. The big thing here is when we start thinking about model training, Databricks is really phenomenal from the model training side. But here's what it doesn't do as well. Data ingestion and analytics are not as strong. And so the idea is it would actually be a really good complement. The idea being that you can actually serve up aggregated data from SingleStore out to Databricks that you can then feed into your model if needed. And so the idea is you can actually lens a lot more and push a lot more data into SingleStore first, right? That can be your main operational store. Batch off any data, whether we're talking pure analytics or even just small amounts of that data into Databricks directly that you can then feed and train your models on. Okay. Yeah. Anuj asked a really, really great question about what's the difference between Snowflake, Databricks, and SingleStore, right? First, it's going to be down to the architecture. SingleStore is a distributed database at the end of the day, right? And so because we're a distributed SQL database, right, you only ever need to know SQL. We integrate a lot better. So Snowflake is an incredibly locked down platform. They have their own proprietary storage mechanisms, and they're going to cost you an arm and a leg to really get data anywhere. And on top of it, they're just expensive to run, right? And so because of that, anytime you run analytics, especially when I was doing it before SingleStore, I was working with Snowflake, right, in a Snowflake environment for 2 years, right, doing high level analytics for C-suite executives at banks. And so when I was doing that, I'd be happy if responses were in the minutes or tens of minutes. At SingleStore, I'm happy if a response takes 5 milliseconds, 10 milliseconds. If a response takes a minute or even a couple seconds, that's unacceptable to me now. And so it's just a different level of it. When we think about Databricks, SingleStore, generally speaking, is going to be more efficient on the analytics side and better on the ingest side. There's a lot that Databricks does well, though. And so when we start thinking about data science, for instance, Databricks is a really phenomenal platform for data science. And so I'd absolutely lens it there, right? There's absolutely a ton of opportunity between Snowflake, Databricks, and SingleStore as well. And in fact, in many cases, we are actually co-sellers. So with Snowflake, for instance, we're a co-processor, and I'm actually going to be at a lot of these Snowflake events. I presented to a lot of Snowflake sellers as well around this. So big idea there. And the follow-up question to that was also, we're talking about semantic search, but the enterprises are struggling first to create a semantic layer on which that semantic search could run. How can SingleStore help create the semantic layer? Now, in the end, SingleStore can do this in 3 ways. The first one is centralization and unification of data in a standard, right? A very actually standardized way, meaning that I don't have a bunch of databases that are different. Each one is going to have their own proprietary format that I have to ETL or move data through. Okay, that's the big one. The second one is speed, right? When you create a semantic layer, you need a lot of data, which can easily be stored. And when we think about SingleStore, we can store an infinite amount of data on the object store. And as you need that data can be brought back up on disk where, again, you can then analyze it that much more efficiently. But the big thing here is its speed on the responses, right? That's a huge one. So we can build out a large amount of data, but we can also analyze that data incredibly efficiently. The last piece is scalability, right? When you start with a single node and stay with a single node database, trying to upgrade it and change that around can be incredibly hard, right? SingleStore is built with that sort of scalability in mind. And so those are the 3 major reasons why I would absolutely think first and foremost that SingleStore can help build out a semantic layer. Okay. And so Anuj is asking another great question. What's the cost difference between Data Lake, Hudi, Apache Iceberg? What a great question, right? So here's the biggest one. When we start thinking about Delta Lakes on Databricks, or really, well, actually, I think it's basically Databricks. generally speaking, it's just a different way of really ultimately working with the data. Especially when we start adding in something like Iceberg. Iceberg is one of those new standards that if you haven't heard yet, I highly recommend you go out and take a look, right? So Iceberg, when we start thinking about it, and actually, let me bring up a really cool slide. So I am giving you a little bit of an idea, a big champion for Iceberg for SingleStore. And so, I'm really happy I got this question because I just think it's absolutely phenomenal. So let me just go bring this up really quickly. And I apologize for some of the delay on this. But ultimately, when we think of Iceberg, Iceberg is Apache Iceberg at the end of the day. What that means is you have basically a front, a catalog, and an external volume. And the external volume is for all intents and purposes, a blob storage. It's an S3 bucket. The idea here is it's an open standard that allows customers to unify their data and standardize their data in a blob storage, meaning that it can be pushed into and taken out by a variety of databases. SingleStore, by the way, can support Snowflake, which we've had now since our last release over the summer, around like June, July. We're going to be building out external tables. We're going to be able to push data back into Iceberg, and that's just on the Snowflake side. We also support Polaris, Glue. We're going to be supporting REST, or we support REST as well. And really, the sky's the limit on it, right? And so Iceberg is one of those great options where fundamentally it's just dramatically less expensive to store your data in a blob storage, which is the same reason that we have our object store as well. And so, Iceberg is one of those really, really powerful places where you can just easily store the data, take the data down, push it back up. And there's a lot of major enterprises that even I'm in discussions with and SingleStore is in discussions with around this, because it builds out when we start thinking not quite exactly Delta Lake, but in that way, right? Where you don't just have the database anymore, right? And you don't just exactly have the warehouse, right? You have the lake house, and then of course, now we're building into the Delta Lake side, specifically on the Databricks piece. But overall, I'll end it this way. SingleStore absolutely believes in flexibility in that agnostic thought process. And that's why, if you remember on that last slide, and I'm sorry I can't find the slide right now for Iceberg, but here's the big one, right? If you remember that last slide that showed all of the LLMs on the right, let me bring it up again. Yeah, let me bring it up again. So this way everyone's on the same page, right? Hopefully it'll come up. Okay. Yep. If everyone remembers this, the idea is we want you to take any model that you want to bring in. That could be a public model, a private model. It doesn't matter to us. We want you to use your data. And so when we start thinking about data storage cost, we don't try to make money on your storage cost, right? It's basically flat for us. The idea is we want you to use our service, right? And so the idea is when you spin up SingleStore, as I said before, you don't pay per query. You reserve an instance with a certain amount of CPUs, a certain amount of RAM, a certain amount of storage, and you can load as much data onto there as you want. Try to hit the system with as much as you can, 100% utilization, 80% utilization, 90% utilization. That's awesome, right? That's what we want. We want your complex problems. We want your challenges. We want a lot of those, tough use cases because we know the system can handle it. The best feeling for us is when we get a tough challenge that your company has had for a long time, and we get to sit there and help build a long-term lasting solution for you. It's really that amazing. Whether it's for the biggest company you've ever heard of or a startup that is pre-alpha or even pre-seed, we are happy to support you any way, shape, or form. And that's just not me saying that, that's the company as a whole, and really putting our money where our mouth is. Okay. Now, that's all the questions on here, and I don't want to take any more of your time. Again, thank you all so much for taking the time, listening, and for so many of you for staying after. I really, really appreciate it. And the other thing that I'll note is that notebook that I just showed you. Now, it takes a couple pieces, right? So you need to go, and there are a couple spots where you need to grab credentials to actually be able to run it. But the notebook is actually sitting right now in the chat that you can download off of that public bucket. And I'll keep the data live in that public bucket for a while, okay, for a couple months, or until I'm told to take it down, right? So with that being said, Yukti, back to you. I don't think there's anything else I can really say unless there's another question that comes in last second.
All right. So thanks everyone for sticking around, and thanks Justin for taking out your time and actually going 10 minutes over to answer all the questions. So as promised, we actually take up all the questions that are thrown at us live. So if our team is not really able to catch up to all the questions, we actually follow up with folks afterwards via email. So if you have any questions that are still there in your head, feel free to email us at team@singlestore.com, or you can reach out to me on LinkedIn, or maybe even Justin. Like, just feel free to drop in a message regarding any feedback or any ideas on future sessions. So yeah, thanks everyone for joining, and have a great rest of the day. And to folks in India, have a very happy Diwali, and take care, everyone. Bye bye.
Absolutely. Thank you all very much. And if you're going to be at AWS reInvent, I'll see you there.
Awesome. I hope people actually go and meet Justin at this point.
Okay.
All right.